I think we're up and online. I'm gonna get some stuff set up. I've obviously never done this, so hopefully I can get you guys a link for the live stream. Set up. I've obviously never done this, so okay, there's the YouTube. But no, I just gotta wait for you guys to get on, I guess. Don't know how this will work. We'll see. Got the iPad. Number 3 and 4. Okay. I got you, buddy. So check this out. You're given the interior angle sum first. Or sorry, that's not number 3. Ha, there's number 3. Measure of one interior angle. So with one interior angle, what you've got to remember is that there is a relationship between that and the exterior angle. So if I want to go from here to here, you can do 180 minus your 120, and that'll give you 60 degrees. So with 60 degrees there, now I know, hey, I can now set up my equation of 360 over n equals 60. And so this is something you're going to want to solve. You're going to multiply both sides by n, and I'm going to cheat a little again. Of course, nothing's perfect, but that's okay. Ivy. Let's see if I can actually get this right now. There we go. And so when you're solving for n, you get 360 equals 60n. Divide both sides by 60. So then you get n equals 6. Now that you know the number of sides, you can go right back to the beginning here in column 1 where it says number of sides. You can plug in a 6 right there. And now that you know the number of sides, now you can go do your interior angle sum, which is n minus 2 times 180. So then I believe that gets you 720. What's up, Thomas, my boy? Oh, and then of course, this third column, a lot of people were asking, Mr. T, why is the exterior angle sum always 360? And you got to remember that's actually one of our theorems. It was the first theorem after our equation on 8.3, 8.4, which basically states that no matter what shape you have something like this, you could have a 20-sided shape. If you take all those exterior angles and you add them up, you will always get 360. No, 360 divided by 60. Now going on to number 4, right over here, again, I don't have any sides. The only thing I know is the exterior angle. So what I can do here is the same thing as above. We're going to say 360 divided by n equals 10. Yes, that's exactly it, Matthew. So when you multiply both sides by 10, or sorry, by n, you get 360, I can write, equals 10n. And so then dividing out both sides by 10, you do get n equals 36, which is a lot of sides, but that doesn't matter, because now we go back to the front, we say there's 36 sides. You can go right here to this, and you can say n minus 2 times 180. So I believe that's 34. And of course I don't have a calculator in front of me, and I've already worked these out, but you will get your answer there. Now there are two ways of getting your measure of one interior angle. You can either take your 10 degrees from the last one and do 180 minus 10 to get your 170. That's the easy way. Or if you've already done this work so far, what you can do is you can now take the answer that you would get here and you would divide it by the number of sides that we calculated earlier, 36. So hopefully that helps you out a little bit, Matthew. I'm trying not to have the volume on because I'm hearing my echo, and because it's like a 2-second delay, I don't want to be like, freaking out, what am I saying? But yeah. Hopefully that helped out a bit. Thomas, did you have any questions for me? Yes, no, maybe so. Unless he's just hanging out, because you know, what else are you going to be doing on a Sunday evening besides studying for your math test? The next one was a kite question. Okay. Well, Matthew, if it's a question on specificities of a kite, you can just ask it right there. Sam, I'm going to go ahead and get your number 9 right now. So, of course, we have our 60 minutes until, oh my goodness. Okay. So anyway, Sam, we're going to be doing your number 9, which, of course, we want to find the area of our trapezoid. So the first thing I acknowledge is that I'm missing my base 1, and I'm missing my height. Well, by drawing in my height right here, we create for ourselves our special right triangle. So right here, the 60 degrees is pointing to the long leg, which is our height. Now this little section here is our short leg. The key thing to be careful with, though, is you want to remember that 17 represents the entire length, right? So you don't want to say, oh, 17 plus this side and then some other stuff. We don't want to get confused there. So let's go ahead and solve for our short leg first. So since our hypotenuse is 12, let's call that x, because why not? So then dividing both sides by 2, I'm going to fix that marker because it's a little too There we go. Divide by 2. So then we get x equals 6. So this little part down here is 6 units long. Now, I can instantly find base 1 because what I have to remember is that base 1, the length for base 1 is equivalent here and here. So if my total length was 17, and I know one part of it was the 6, then that means I can do 17 minus 6, and that gives you your 11. Now we still need the height, which of course, if you recall, that's still our long leg. So we can say that the long leg, oh, I don't know why, let's fix that. There we go. So we can say that the long leg is equal to the short leg times rad 3. The long leg is the height. The short leg we just calculated earlier was the 6. So our height is 6 rad 3. We've got our top base, we have our bottom base, and now we have our height. So now it's just plug it in. So then right here, we're going to say 1/2 of 11 plus 17 times 6 rad 3. Now notice on our answer it says leave it in simplest radical form. So what I want to be careful for is make sure I don't just type this straight in my calculator. I want to be a little creative with how I use my commutative property of multiplication to help me out. So let's first simplify inside the parentheses. So 1/2 of 28 times 6 rad 3. So of course we could take half of 28 first. So that would give me 14 times 6 rad 3. Don't distribute the 1/2 to both numbers, only to one. And I'm choosing the first one. Could you have chosen the second one? Of course you could have. But be careful about, don't give it to both. You don't want to do that. So then 6 times 4, that'll be 24. 6 times 1, so I believe that's 84 rad 3. And what are my units? Don't forget those. Feet squared. And so there's our area, Sam. I hope that was able to help you a little bit. All of these solutions have already been worked out if you go to your respective notes pages on your classroom. But I figured, hey, let's redo some of these problems and, give you a fresh start. Yes, if you take half of 6 rad 3, it would be 3 rad 3. And so, Matthew, in your case, you would have 28 times 3 rad 3 instead of 14 times 6 rad 3. I got 7 people watching, 8 people. This is kind of cool, kind of fun. You guys are awesome. How's the sound quality out there? I wasn't able to test anything. Minju, our test is tomorrow. I pushed it back already from last Friday and Thursday. Yes, Matthew, you're awesome. But, when I beat you in that Pokemon battle, don't get too offended, Still got to show you how to play. I told everyone. No excuses. questions? Yes, no, maybe so. Potato, potato, tomato, tomato. The next one. So you want to do number 10, Mateo? So on this one, we have two special right triangles at play. You have your, sorry, 30, 60, 90. And then you have your 45, 45, 90 triangle. So we want to be careful with this, because something that I want to emphasize with y'all is how do you multiply radicals, or how do you multiply add things that don't add together. As weird as that sounds. Way back when you were in Algebra 1, which hopefully was last year, but it doesn't matter. You were doing algebra stuff, you were saying, hey, if I have 5x plus 12, you can't combine those two terms, so therefore you kind of left it alone. And that's kind of what we want to do here. No, Daniel, we are not doing Fortnite. Bad. But let's take a look here. I know that this part of my triangle is going to be equivalent to this part here. Now in the kite, you want to also remember that the longer diagonal bisects the shorter diagonal. So that means that this part is also equal. So once we find our first answer, we just kind of rewrite it 3 times. So taking a look at the special right triangle there, we know that this side length is 6. This is our long leg, let's call it x. So long leg equals short leg times rad 3. So therefore we say that that leg is 6 rad 3. So the diagonal for this part here will be 6 rad 3 plus 6 rad 3. Which will be 12 rad 3. Now the other diagonal's not as easy to recognize because, like I said, it's been a while since some of you have done this. But when you're combining these two, since this one is 6 rad 3, and the other one is 6, we can't actually add them. We can't say it's also 12 rad 3. That's not how it works. So what we instead say is that diagonal 2, come on, is equal to 6 plus 6 rad 3. Right, just as an example, it would be the same case, exactly. So right over here, when we actually compute the area and use the formula, now I know some of you guys have been preferring the other formula. I'm sticking with this one because the majority of the classes have been okay with this. So we found that diagonal 1 was 12 rad 3. Diagonal 2 was 6 plus 6 rad 3. So to minimize any confusion, what I'm going to want to do, yes, we can go back to number 2 in a bit. And, sorry, train of thought. We're going to want to be creative again with our commutative property. So let's take half of your 12. So half of 12 is going to be 6 rad 3. And I'm going to multiply that by 6 plus 6 rad 3. And if you remember what happens with multiplication and addition, especially in a grouping, you would distribute it to both. So what you're going to do then is you're going to do 6 times 6, which will give you the 36. But we've got to carry down our rad 3. Bam. Let's see here. Jonah, just type into the chat box, and then I'll be able to hear you. Alright, so then 36 rad 3 was the first one. The second one, we're going to again do 6 times 6, but we also have to do rad 3 times rad 3. So what that will simplify to is 36 times, well, rad 3 times rad 3 is rad 9, but the square root of 9 is 3. So we will get 36 rad 3 plus, what is that, 18, 108. And then, of course, we have our units, meters, so then we'll say meters squared. Now, in terms of order, it doesn't matter if I write the 36 rad 3 first, plus the 108, or if I write 108 plus 36 rad 3. Either way works out fine. Let me actually respond back to Jonah on the remind message real quick before we go to number 2. Okay, so we're going to go ahead to number 2. Uh-oh. Messed that up. I should probably do a screen lock first so that I don't have that happen again. There we go. Much better. Okay. Let's see. Okay, so back to number 2. Right here, I'm given my interior angle sum and nothing else. So what I need to remember was that I had a formula that gave me this number. That number was n minus 2 times 180. So I'm going to set that formula equal to 2,340. Now from here, you have a couple options. You can either distribute the 180 and then solve it, but it's easier if you actually divide both sides by 180. So by doing that, I actually simplify the entire problem altogether. So I believe n minus 2, oh my gosh, why do I have to? I love my calculator in the classroom. And here I am telling you guys, always have your calculators on you. It's a good thing my phone is ready. So that gives us a nice 13. But I gotta add 2 to both sides. So then n equals 15. So now that I know what n equals, we can go right back here and remember that your measure of your one interior angle is just the total sum divided by the number of sides we have, which we literally just found. Which I can fix on my calculator. And that gives us a nice, beautiful 156. Well, there are certain things that we are okay with using our calculators for. Obviously, you guys should be able to do certain things, practicing your arithmetic, but you know, there are obviously trig functions that we're going to need calculators for. You guys kind of got to know it. So don't worry about it. So anyways, we have our 156, which was here. Again, back to what we said before, the sum of all our exterior angles will always be 360, no matter what. Now over here, we have the nice and simple formula, 360 over n. So what we're going to then say is 360 divided by 15. So 1530, 4560, so that's going to end in a 4. And then I believe that's 24, but I could double check. Or wait. I believe our other method, and again I'm going to shrink this down. We could also say 180 minus the angle that we just calculated, which was the 156, which indeed also gets us 24. Now I know Jonah sent me a message earlier, but I have to double check it because he probably didn't. Oh no, he said it. There's a chat. It's weird. My remind says I have another message from someone in period 6, but I don't see any other messages. Oh well. Are we multiplying 180? For which part? We didn't have to multiply by 180 on any of this because the entire thing we already had the angle given. So you actually divide the 180 to get your number of sides. You do the total angle divided by the number of sides. And again, 360 divided. So no, there's no multiplying by 180. You would do that if you know your number of sides for like number 1. Which I believe is 900. No. 1080. I don't know why I thought that. Alright. Any other questions? Yeah, I can finish up number 1. I kind of started it for you, Charmaine. So again, you have to remember your interior angle sum. You have that beautiful formula, n minus 2 times 180, whatever the sign for 8 is, 6, 7, 8. There we go. Now the measure of one interior angle, if you want to redo the formula, Charmaine, you could say n minus 2 times 180 all over n, but you already did the n minus 2 part. That's what this number was here. So what we can do then is we can actually kind of copy and paste our number here and divide it by the number of sides we were given, which was 8. Yes, Kasha, we can do number 5, of course. So back to this, 1080 divided by 8 gives us our nice 135 degrees. Raymond would make this 100 times better. Probably. So anyways, back to this. The exterior angle sum, you gotta know that is always 360 degrees. So then the measure of one exterior angle, you again can do 360 divided by 8, which will give you 45 degrees. Or you can do 180 minus your 135. And the 135 again comes from here. Oh, come on. There we go. So then again, you're 45. So hopefully that helped you out, Charmaine. If you still got questions, of course, y'all can bother me tomorrow morning. Or, sorry, not bother me. You can come in and get all the extra help that you need. Yeah. Okay. So, Kasher, you wanted to do number 5. I got you, my boy. So we're going to actually put into practice the theorem that we wrote over here, the exterior angle sum. So because the angles are outside, we're going to go ahead and set all those angles added up and set them equal to 180, or sorry, not 180, 360. So this plus this plus this plus this. So we're going to say x plus 40 plus 2x plus 20 plus 3x plus 6x. So Kosher, we're going to go back to Algebra 1, and we're going to go ahead and combine the like terms. So we have x, 2x, 3x, and 6x. We also have the 40 and the 20. So that is 9, 10, 11, 12x. And then we have 40 plus 20, which is 60. So that'll equal 360. So then going back into our first step of our two-step equations, got to move that 60 over. And you're welcome, by the way, Charmaine. 12x equals 300. So then from here, we go ahead and do 300 divided by 12. And that sounds awfully familiar. I think that's 15. It's either 15 or 25. I'm going to double check that. Yeah, 25. So hopefully that helped you out, Mr. Kosher. Again, if I gave you a 3-sided figure, if I gave you a 10-sided figure, I wouldn't be that mean. Or would I? Whatever number of sides I give you, it's always going to be adding up all the outside angles and setting them equal to 360. All right, Kosher? Jonah, we're going to go ahead and do 12, and yes, Pauline will go ahead and tackle 15 as well. So let's go ahead and jump right to that. All right, so Jonah, before we do number 12, I need you to remember something for me. Besides the fact that you need your calculator with you, you got to remember that you have to be able to label the triangle inside of your shape. Okay, so first off, if I write my formula, area equals 1/2 apothem times perimeter, I want to try to figure out how to get my apothem and my perimeter. Now, unfortunately, I didn't make this one easy on you. I gave you the radius. So with our radius, we have to remember that that line is always drawn from the middle to a corner of your shape. So that'll be here. All right. Now this is 6. I could also draw another radius here. That would also be 6. So with my radii drawn, I need to also draw in my apothem. The apothem is what we need. So I'm going to label that as A. We're also going to need the perimeter. So in order to get the perimeter, I need to calculate the side length. So I'm eventually going to need this length as well. And before we get too much further, let's also try to figure out the angles up there. So first off, since we have a 5-sided figure, we're going to say 360 divided by 5, which will give me 72. That's exactly it. So with 72, we got to split it in half, because our apothem always splits that angle. We're going to get a 36 degrees. Yes, Mateo, that is correct. So right up there, each of those tiny corners up there, which if I redraw this triangle here, That means the top angle here is 36. And I'm going to relabel my apothem there. And my radius. Can't forget that. So at this point, Jonah, you should be able to recognize that 36 degrees is not one of our special right triangles. So I'm going to want to use my trigonometry. Now, if you have to redraw the stick figure, that's okay. But remember that the side next to our stick figure is the adjacent, and the side that is across from the 90 degrees is our hypotenuse. So if you think back to SOHCAHTOA, you should know what trig you're going to use for this one. And it should be cosine. So we will say cosine of 36 degrees equals the adjacent over the hypotenuse, which is my a over 6. We're going to multiply both sides by 6. And so that'll give us a equals 6 cosine of 36 degrees. Now that's going to go in your calculator, which of course I'm using my cell phone. Got to turn it sideways, yo. Now, I do want you guys to avoid rounding halfway through. I want you to try to keep all the numbers in your calculator. However, if you can't, it's good to have 4 decimal places, right? So 6 cosine 36. So that is my 4.8541. No, we are not going to dab. You weirdo. Bam. Oh, I should probably read the comments more because Jonah's already on top of it. So there's my apothem, but we still need to find the side. So if you remember from our figure here, these 2 side lengths here get split in half. Isn't it true the answer would be slightly off? It would only be slightly off to like the 5th or 6th decimal. Once you have 4 decimals, it's not going to matter as much, especially since we're rounding to the nearest 10th. You guys are funny. Okay, so back to this, Jonah. Stay focused. We need to solve for the bottom sides, which are down here. I'm going to call them B. So if you remember that this bottom side is the opposite side, I need the hypotenuse and the opposite, which means I'm going to now use sine. Now, before I move on, I'm going to box A because I'm going to try to visually see, hey, I need this numbered later. So we are going to say sine of 36 equals a over 6. Thank you, by the way. So multiply both sides by 6 again. So then you'll have a equals 6 sine of 36. Now I know that's going to be significantly smaller. 6 sine 36, so 3.52. So why did I put A? I meant to put B. You guys got to catch my mistakes a little quicker. We're using sine because it's the opposite over the hypotenuse. Right. So now that I have the side length of B, and I realized I don't actually want to box that because that number is the length of that side. Well, I don't want just that small part, I need the entire length. So if you still have the number in your calculator, just hit times 2, and you will now have the length of one side. So the one side on my calculator says 7.0534. Mateo, we don't want to just say times 10 without justifying why. Let's keep it simple. Do you always have to use bottom? I would avoid using A, Anthony, because it was a rounded answer, and plus you don't want to have to retype all those decimals. It's nicer to just work with the 6 that was given to us. So back to this, my perimeter is going to be the length of my side times the number of sides that I have. So I have 5 sides times my 7.0534. And again, if you still have that number in your calculator, just type in times 5. So I have a 35. I'm going to move that. .2671. Let me fix that up. Okay, so now we have our perimeter. We have our apothem. We're good to go. It's always fun trying to see everything at once. 1/2 4.8541 times 35.2671. So again, just type it all straight in. Don't even try to do it one step at a time. Just type it all in. Let's see here. And hopefully, if you type this in right, you will get 85.59, etc. Now I'm only writing 2 decimals because I want to make sure you all know we're rounding to the nearest tenth. So I'm going to look at this decimal here. I look at the number behind it. The number behind it is 5 or more, so therefore it will round it up to an 85.6. And again, going back to our units, we add feet, so this will be feet squared. So hopefully that was helpful to you, Jonah. Gotta scroll up because I know someone asked another question earlier. 16 and 12. So we are going to do 15 next. We just did 12. I don't know why I said that. We're going to go ahead and do 15 and 16 next. Jonah, to answer your question, I think I only put 1 because, in all honesty, these types of questions take a while. So if anything, for sure 1. And also remember, I am giving you all extra credit. So the extra credit, again, like I've said, is a question that you have never done before. I've never taught the lesson for it, but I've literally given you the steps for how to do the problem. So if you follow the directions, you'll be fine. Would it be possible to make questions? Like, make up additional types of these questions, Mateo, or what do you mean? It's an area question. It's not like something unrelated. It's all area. Because what you haven't been, so something that the honors kids have learned. Yeah, I mean, if you look on the why can't I remember it? Not pizzazz. What game did we play on Friday? Why can't I remember it? Kahoot. If you look at the Kahoot review, Mateo, I gave you like 5 or 6 questions. So you should probably try those out if you want to give yourself extra practice. Cool. So, back to this. Pauline, you had a question on number 15, so we'll go ahead and do that. So I'm trying to find the area of the shaded region, which you can see looks kind of like the red cross. Now what I want to try to identify is say, okay, how am I going to get this? Well, I first identify that these gaps are in the corners, and they're all rectangles, technically squares on some of them. So I should be able to find them by doing just base times height. So we can do 5 times 5, which is 25. And that's actually the same for all 4 of them. Bam. Now, what I want to do is I want to recognize, hey, the overall shape is a rectangle of some sort. Could it be a square? Of course it could be. But the overall picture is saying, hey, I have a rectangle, so I want to find my base and my height. So the bottom base length will be a 14, and the right side is also a 14. So ideally what I'm trying to do here is I'm trying to say the total area minus the unshaded area. So that's going to be 14 times 14, which is 196. Those 4 regions is just 25 times 4, since you have 4 of those areas, which is 100. So then you're going to want to do 196 minus 100, and that'll give you a nice 96. And again, don't forget your units. Hopefully that helped you out. Yes, no, maybe so, potato, potato. Now, number 16 is actually going to be almost exactly the same thing. So let's go ahead and jump right to it. So 16, I identified that I have a triangle, and I want to take away the area of that invisible rectangle, you could say. So what I want to pretend is say, hey, this section is actually cut up, or not cut up, filled in. So this area here is the area of a rectangle. So we know that that's going to be just 7 times 6. So 42. But in order for me to find the area of the triangle, I need to first not just know the height, I need to also know the base. So my base is going to be that entire length, which is made up of this 2 plus this 7, sorry, plus the 4. So my area of my triangle is going to be 1/2 of 7 plus 2, 9, plus 4, 13. So 1/2 of 13 times 10. So if you choose to type it in your calculator, that's fine. Sorry. Or if you want to be smart with your math, that's fine too. I'm going to do that. That's the same as 13 times 5, because I took half of my 10. So that is 13, 26, 39, 52, 65. So we'll have a 65 centimeters squared. Jonah, were you surprised that the solution was much simpler than you initially thought? I could imagine him just saying, oh my gosh, son of a gun, Mr. T. This kid. So let's see here. We've answered, so far I think I've answered all your questions. Yeah, I've answered all of them. Cool. Oh, you kids are funny. Yeah, so are there any other questions that I can answer for y'all? Hi, Trinity, also known as Boba T, my girl. So it was funny. I was actually hanging out with one of my friends the other day, and I was telling her that this week was kind of rough for me because I was partially sick, and I was saying that I think my kids got me sick, and she thought I had children, and I was like, no, 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 not my own biological children, my students. You are all my kids, in my mind at least. So yeah. Any of you have any questions? I know some of you might be jumping in late, which is totally fine. I can always go back. It says 23. 23. Oh, well, I'm not done yet, Kosher. It would have been helpful if I finished that. Yeah, so how about, Kosher, that we say 65 minus 42? And there's our 23. How about that? See, this is why I need you guys to check this. I think we did 15 already, Kosher, so I can show you the work again if you need for a little bit. Yeah, we did the work already. Right there. Let's see here. Anthony, you said this is hard. I mean, part of it is just being able to recognize your shapes, Anthony. It's, you know, if you can recognize that you have squares, that you have triangles, trapezoids. If you recognize, hey, I don't have a special right triangle, what do I do instead? Right? It's mostly you trying to recognize your situations and say, what do I do? What do I do here versus what do I do here? Right? So that's something you're going to need to recognize. And you have a little bit more time than they do, Anthony, so you could come in tomorrow during lunch and get some help from me. Let's see. Kosher meant number 16, which, oh hey, we just did number 16. My boy. You guys are funny on the extra credit. So funny. So funny. Charmaine, we can do 14. And then I'll jump back up and show you the work for 3 and 4. I've never done the live streaming, obviously, but are you able to jump at any point in the time? And then just kind of like jump to that section, or how does it work? Do you have to wait until the video publishes? I don't know. Never done this. But yeah. So Kosher, did that help you? Mateo says yes. It's live. Well, I know it's live, but I mean, if it's live, could I jump back to like, okay, so you can skip back. Okay, cool. So Charmaine, if you want any explanations, you can jump right back to like literally the very beginning. We did numbers 3 and 4. But yeah, I can show you the work in a bit too. So, okay, good. Kosher is good. So let's jump to 14. Charmaine wanted 14. Ah, yes. Yes. This was your last formula that you all learned. So you better have it memorized. There's only one question. Okay. Area equals 1/2 BC sine of A. What the heck does this mean, Mr. T? Good question. Well, this is a side angle side triangle. And with a side angle side triangle, you can use this formula right away. So we can say that this is B, this is C, and then this is our angle, which is going to go into sine. So what we're going to do there, just plug it in. Sassy triangle. Yes, it is a very, very sassy triangle. Pull up that calculator, yo. Alright, let's see here. So 0.5, which is my 1/2. times 11 point, why did I say 11 point? I meant to say 11 times 7 times sine 53. So you should get 30.7. Round to the nearest tenth. After the 7 is a 4. Now hold on. I'm going to address something that hopefully you guys do not do on your test. I'm going to write the next digit after that to show you. If it says round to the nearest tenth, you only look at this number and look behind it. Don't all of a sudden say, oh, Mr. T, the 7 rounds a 4 up to a 5, and then the 5 rounds to 7 up. That's not how we do rounding. If you do that, I don't even want to think about what's going to happen to you if you even try to do that. Don't do it. So we're going to just get set 30.7 meters squared. No, Kasher, it does not matter which number you put for B or C. You could have done 7 times 11. It doesn't matter. It's all multiplication. So just like when we did the law of cosines, it didn't matter which one you had for B or C. Same thing. Trying to see who, Charmaine asked this one. Yeah, so Charmaine, hopefully you were able to get this. Keyword is hopefully. All you literally have to do is plug it in, so there's not really... Oh, she's answering the question about that. I was like, oh, she didn't get it. Okay, yeah, so that's literally all you do. Let me look up. I wonder if there's a way to make the chat window bigger. Oh yes, the pop-out chat. Here we go. Yeah, this will be easier for me to see. Oh my goodness. Oh, I guess you can have the pop-up chat even show up on the stream too, huh? That'd be cool. More ideas for Mr. T. Cool. Okay. So Anthony wants to do number 18. We can totally do that. Before we do 18, Anthony, I'm going to go up to numbers 3 and 4 to show Charmaine in case she has not gone back to take a look at the other ones. Or sorry, not the other ones. The replay, if she didn't replay these ones, just so that she could see the screen. She could, of course, hit the pause button and then go back. So number 18, my boy, Anthony. There are a couple ways of doing this. There are realistically 2 approaches you could take. And I'm going to actually jump to the other page to show you because it'll be easier to do that. Oh, of course my thing freezes. Huh. Good job, Mr. T. The whole thing is shaded. For which one, Jonah? I guess he's assuming for number 18. So the reason I say find the area of the shaded region is because you could say, hey, I can break this up into 2 trapezoids. So then there's your shaded region, your trapezoid 1. You have a base of 7 and 3. And of course the order doesn't matter. Now this base here is also the same as for the trapezoid 2. So that would be the same idea there. So it sounds kind of contradictory for me to say find the shaded region if the entire thing's shaded. But if you decided to do a different approach and say, hey, I can look at this as an entire rectangle and subtract from it the area of the triangle, which would be the unshaded region, then that unshaded region would be a triangle. So that's why I put those directions in as they were. So Anthony, hopefully you could see that this 2 and this 3 give us the total length there as a a 5, and that taking my 7 from the top over here and subtracting the 3, I get the 4 right there. Hopefully you're able to see that. And so that allows me to say, hey, my base is 5, my height is 4, but I'm going to take half of it because it is the area of a triangle. And so then I have my two areas, my 7 times 5, the top side of 7, also the bottom, same thing, and the total height gives me 35. So then I'm doing 35 of my total minus the 10 of my little part, which gives me my 25 with 10 and 15. Oh, well, all we're doing it is adding it. We're just adding the two areas. So if you recognize that you have two trapezoids, let's say there's the green trapezoid here, which would be this area. And I'm gonna, oh, I should have thought that one through. Let's try this instead. The green trapezoid here, which would give me this area here. And then the yellow trapezoid, which would give me this area here. And so I'm adding the two areas together. I'm not doing anything fancy with them. I'm just saying the top trapezoid has 10 units, the bottom trapezoid has 15, and so 10 plus 15 gives me my 25. By 2 and 3. Okay, glad you asked that. So right here, Anthony, on the yellow trapezoid, the 2 represented my height of trapezoid 1. My 3 represented the height of trapezoid 2. That's why we multiplied by 2 and 3. Because remember, it's 1/2 base 1 plus base 2 times the height of the respective trapezoids. Did that answer your question, Anthony? Yes, no, maybe so. I think so. Okay, and again, if you want to come in to get more help, Anthony, you're more than welcome to. Okay, knowing that half the class is going to start jumping in, that works too. So let's go ahead. I'm going to jump right back to our other one. Hopefully it doesn't freeze. And of course it freezes. Yay! Gotta love cross compatibility. So Pauline, let's go ahead and do number 17 then. Oh, wait, we already did 17. No, that's for the other one. No, I want this one, the blank one. Oh, it's frozen. Give me a second. Time for Fortnite. No, we are not doing Fortnite, Jonah. Bad Jonah. Okay, cool. So 17. Pauline, are you ready? Yeah, no, it's going to be too late by the time she says yes. So what you want to be able to do is you want to be able to cut this shape into 2 equal parts. No, I am not hitting you up on any game consoles, children. So right here, Pauline, I create 2 distinct shapes I can find the area for. We can find the area of the trapezoid, and we can find the area of the rectangle. So I'm going to draw a little line here that is going to represent my height. Well, if you remember that the total height is 16 over here, that's the height from the very top of the figure to the very bottom. This aid represents the height of this side here. So what I'm going to do is I'm going to do 16 minus 8, and that's going to equal 8. So for my trapezoid, the height is 8. Now, looking at the figure by itself, I still don't have base 2 for my trapezoid. But this 18 down here is actually the same length as this bottom side right here. So what we can then do is we can say, well, now 1/2 base 1 plus base 2 times the height. So 1/2 of 12 plus 18 times my height of 8. So then 1/2 of 30 times 8, which will give me 120. But that's the area of the top part. I still need to combine with that the area of the bottom. So what I'm going to do is I'm going to do the rectangle. And we know that that's just going to be base times height. So then my area will be 8 times 18. Which I believe is 144. Yeah, so that's 144. So then my total area is the 120 plus 144. And so there you go. Hopefully that helped out. Yes, no, hopefully so. Let's see here. Cool, you're good. Was there anyone else that was interested in any other of the problems that are on the review? Oh, they have timestamps. That's so cool. So hypothetically, I can put in the timestamps for which questions we covered. Can we do number 8? Yes, we can. Yes, we can. I don't think we did number 8, so we should be okay. Alright, so this one's actually a good one, because this one was exactly the same type of question I gave you on that practice quiz. I gave you an isosceles triangle. Now, if at this point you still don't know what to do with an isosceles triangle, then you're in some trouble. Okay? So you got to remember that since these two sides are equal, what happens then is that I can create an altitude. Now this altitude is the height. This height splits the bottom side into 2 equal pieces. Now again, since I have a right triangle now, I can go ahead and use my Pythagorean theorem. Now this 18 represents the entire length of the bottom. 11 and 13. Sure, we could probably get there. So then that means these two are 9 apiece. So I'm going to say h squared plus 9 squared equals 10 squared. So then I have h squared plus 81 equals 100. If I take away the 81 from both sides, I should have h squared equals 19. Now, when you take the square root of 19, you can't do anything to it because 19 is a prime number. It does not break down at all. So h is just going to be the square root of 19. Now, if you think that's going to make things difficult, it won't. It literally makes the entire thing actually even easier. So check this out. We can go ahead and say area equals 1/2 base times height. Again, remember the 18 was the entire base. Don't say 9 is the base. Don't say 9 plus 18 plus 9 is your base. We're just going to use the 18. So we're going to say 1/2 of 18 times our height of the square root of 19. Now, how is this much easier, Mr. T? Well, I don't have to do any work, because all I have to do is take 1/2 of 18. And that's going to be 9, because the square root of 19, can't do anything with it. So then my area is 9 rad 19 inches squared. So that's literally all you do. So hopefully that helped you out, Sam. Keyword is hopefully. Yes, no, maybe so. I'm going to stop saying that because I'm sure you're all getting annoyed from it. So Charmaine, we can definitely do 11 and 13. So let's jump right to it. 11 is there, 13 is there. Okay. I'm not tired at all. Okay. So each side of our hexagon has a length of 12. So right away, Charmaine, I can go ahead and say that my perimeter is equal to the 6 sides that I have times 12, which is 72. Yay! Now we just have to find the apothem. So, here we go. Apothem's right there. I'm going to want to create a triangle. So, Charmaine, you've got to... How long am I going to stay live? Probably just another... Let's see, it's 8:30 already. Like maybe another 15 minutes. I still haven't had dinner, actually. But you guys can always text me messages on Remind, and then I can hopefully help you there. So right here, this whole side length of 12 gets this split into 6 and 6. So then what I need to do is figure out, do I have a special right triangle, or do I need to use trig? So we're going to do 360 divided by the number of sides, which will give me 60. But then you got to remember that we have to take that 60, split it in half to give us our 30 degrees. So that means each of these angles up here are 30 degrees apiece. Whoops. So 30, 30. And then again, here's my apothem. So what I'm going to go ahead and do... Oh, hold on. The work's just now finally catching up. Okay, cool. Sorry about that. So now we're going to go ahead and do our triangle. And we know the apothem's here. Our side length of 6 is here. 30 degrees. And our right angle. So I want to remember that the 30 degrees is pointing to the short side, and my apothem is across from the 60 degrees. No, Mateo, I'm not going to stay on forever. I have a life. That is my long leg. So we're going to say that the long leg equals short leg times rad 3. So A equals 6 rad 3. So with my perimeter and my apothem in hand, we can go ahead and calculate that area. 1/2 AP. So I have 1/2 6 rad 3 times 72. So then again, order of operation, or sorry, not order, commutative property, you can multiply it in whatever order you want, just don't distribute the 1/2. So what you're going to go ahead and do is then take half of, let's say I take half of the 6, so then that'll be 3 rad 3 times my 72. So then I'm going to do 72 times 3. Come on, why is the iPad slowing down? Alright, there we go. It's slowly catching up. So then we're going to do 3 times 72, which is, I believe, so 216 rad 3. What are my units? Centimeters. So centimeters squared. That looks kind of weird. I'm going to fix that. There we go. So hopefully, yes, once you have the power of the perimeter and apothem, you're pretty much set, Mateo. So Charmaine, hopefully that helped you. And I know you also wanted 13, which we could most certainly do. Now there are 2 ways of going about this problem. Okay. So again, 2 ways of doing this. We want to do, we want to first say, hey, we can solve this by using our 1/2 apothem times perimeter. The other way of doing this is using the fact that you know that the square is technically a rhombus, and since I gave you part of the diagonal, you can use the formula for the rhombus instead. So I'm going to show you both ways. So first off, my radius is 7. So that means this length here is 7. And likewise, this here is 7. Now if I were to go ahead and draw in my apothem, this would create for me a 45, 45, 90 degree triangle. Now there are 2 reasons why it's 45, 45, 90. If we do 360 divided by 4, we get 90. Take 90 divided by 2, you get 45. The other reason it's 45 degrees is if you remember in a square, all the corners are right angles. And since we have a diagonal cutting the angle, then what we do is then just cut the 90 degrees in half, you get your 45. So let's extract that triangle right over here. Let's make it a little bigger. There we go. So this is my 7. I'm trying to find these 2 sides here, because I kind of need to find my perimeter as well. Well, those are my legs. Not my actual legs, but they are legs of the triangle. And this right up here is my hypotenuse. So what I'm going to need to do is I'm going to need to use my relationship for my 45, 45, 90, which, if you recall, states that the hypotenuse equals a leg times rad 2. My hypotenuse is 7, and the leg, let's call it x. So then here I'm going to want to divide both sides by rad 2. However, it doesn't simplify anything there. So I get this 7 over rad 2, which means I'm going to have to rationalize it. I need to multiply top and bottom by rad 2. Which should simplify this and that. That was interesting. To 7 rad 2 all over the square root of 4, but we know the square root of 4 is 2. So now from here, this is a little confusing because I realize it's underneath my little thing there. So the 7 rad 2 over 2 is this length here and that length there. So my total side length is going to be 2 times 7 rad 2 over 2. Hey, look at that. The 2's cancel out. So now I have 7 rad 2 as my side length. So my perimeter will be 4 times 7 rad 2, which is 28 rad 2. That didn't work out the way I'd hoped. Not in the slightest bit. We have my perimeter. Do we have the apothem? Technically we do, because remember those sides are equal. So that means that this is also 7 rad 2, all over 2. So, back to the math. Area equals 1/2 7 rad 2 over 2 times 28 rad 2. Let me make sure I wrote that down right. Yep. So now at this point, you're probably thinking, Mr. T, this is not going to end pretty. Well, I promise you, for the square ones, if you type everything straight in, it will always work out nicely. If you don't believe me, that's okay. You can try it yourself. So let's see here. That's going to be... Oh, why can't I math right now? That's going to... So first off, rad 2 times rad 2 is going to give me a 2. And that's going to cancel out with one of my 2's here. So that 2 is gone. These are gone. Now I could take 1/2 of 28. So that'll give me 14 times 7. Don't believe me, just watch. I am not Bruno Mars. So then that is going to be 49 times 2, which is 98 degrees? Not 98 degrees, just 98. Methanes. Just want to make sure. Yeah, 98 centimeters squared. Now that one, obviously, you have to be careful, especially if a radical doesn't simplify or clean up nicely. And then you have to be careful for how you find the perimeter. So with a square, just remember that the alternate method involves the formula for the rhombus and the kite. Because remember that this entire diagonal is going to be this 7 plus that 7. So we could say D1 equals 14. And if you recall, your properties for your squares is that the diagonals are congruent. So that means diagonal 2 is also 14. If you don't believe me, just remember again that that part is also 7. So then 7 plus 7 is 14. So then area equals 1/2. 14 times 14, which I know, oh hey, look, that gives me the same thing. 1/2 of 14 is 7. So 7 times 14, which will give me my 98. Now obviously this one was cleaner, the second one I showed you, but you don't want to, okay, my thing's not catching up again. There we go. So again, you can only do this with a square. I will accept either method, but I want you to do what you're comfortable doing. Hopefully that helped you out a bit, Charmaine. Gotta check our video section. Yeah, I've got 8 of you guys watching, which is kind of cool. I got 8 of you still somehow here. Maybe you've left your keyboard. Who knows? Can we go over number 10? Yes, we could. I don't think I did that one yet. Actually, we did do it earlier, Jafet. So we can kind of talk about it again. It's mostly a mathematical thing. So again, right over here, I've created the special right triangles. So you only have to do the work once, Jafet. You only have to solve for that one side of x. But you have to remember that this side here of 6 rad 3 plus the other side of 6 rad 3 is going to give you the 12 rad 3, which we wrote as diagonal 1. Diagonal 2 is a little different because you have the 6 and the 6 rad 3. You technically cannot add them both together. It's like saying 5x plus 12. You literally can't do 5x plus the 12. You can't magically say, oh, that's going to be a 17. Right? You can't do that. So in the same regard, we treat the rad 3 as a variable. And so we have 6 plus 6 rad 3 as our diagonal 2. So going over to the work, which once my iPad decides to, sweet. So then you'll notice that I chose to take 1/2 of the 12. And so that gave me 6 rad 3 times the 6 plus 6 rad 3. Now right there you do have to distribute. And so the 6 rad 3 times 6 will give you 36 rad 3. The 6 rad 3 times 6 rad 3, you can type that in your calculator, but I also showed the work. You do 6 times 6. You do rad 3 times rad 3. And then once you multiply it all out, you get 36 times 3, which is 108. So then you'll have 36 rad 3 plus 108 meters squared. So, like number 6. Yes, exactly. Like number 6, we are actually, sorry, so number 6, we are not using special right triangles. We are actually using the Pythagorean theorem. So first off, those two sides added together, you get diagonal 1, which is going to equal 8. Now, to find these parts here, you have to set up your Pythagorean theorem. So that's going to be, let's just call that x. So we can say 4 squared plus x squared equals 12 squared. And so for this one, 16 plus x squared equals 144. You subtract the 16 from both sides. So then you'll have x squared equals, what is that, 128? Yeah, 128. And so then x will equal, when you take the square root of that, the square root of 128. But I obviously want you to be able to break it down. Some of you have the calculators that let you do that. Let's pretend you don't have it. What are you going to do? The easiest way of kind of going about this is breaking down your 128. I always find the biggest perfect square that goes into number, because then I know the square root of that number. So I know that 128 is equal to 2 times 64. Well, the square root of 64 is an 8, and the square root of 2 I can't do anything with, so it stays inside of the radical. So 8 rad 2 is what x is. But remember that it's 8 rad 2 plus 8 rad 2. So that means diagonal 2. Oh my goodness, why are you doing this to me? Diagonal 2 will equal 16 rad 2. So then jumping back over to our formula, area equals 1/2. Oh my goodness. So 1/2 of 8 times 16 rad 2. And again, I can be picky about how I want to multiply, so I'm going to take half of 16 first. So that'll give me 8 times 8 rad 2, which will be 64 rad 2 inches squared. And again, the iPad is not responding. Come on. My kids need to see this. iPad, why are you not working? There we go. It's slowly catching up. So hopefully that helped out a bit more, Jafet. If I give you two sides, you're going to use the Pythagorean theorem. If I give you an angle in there, you're most likely going to use your special right triangles. Right? I don't think on any of these ones I'm going to give you trig. The only time it'll be trig is if we do the polynomials. Those will realistically be the only ones that have trig. Any other questions, little critters? Anything I can help you with? We've covered a lot. Literally the entire packet. Yeah, literally the entire packet. Yeah, we did 18. I just kind of redid the work. Or not redid the work. I just showed one of the completed works because it was a little easier for me to do it that way. But everything else I think is pretty straightforward. Anthony might disagree with me, but you know, that's okay. He's entitled to his own opinion. Alright, I'm gonna go now because it's 8:51 and I think the first person came in 7:49. Yeah, so it's been a little over an hour. So again, once I end the stream, you guys will have access to the video. I'm probably not going to do any timestamps because I'm getting a little tired. But send me messages and remind if you guys have questions. I'm here for y'all. I hope you all had a good weekend. And only because you guys asked me to, I'm going to say it. Don't forget to subscribe, hit that like button, and follow me on Twitter, which is, I actually just made recently. It is, oh my gosh, M. Tenorio Mathematics, I think. I don't remember. Oh my gosh. I'm a horrible YouTuber. Horrible YouTuber. Up, and it's not working on my phone. I'll give you guys that Twitter handle later. But yeah, Mr. T Math. I think that's what it is. Mr. T Math. Anyways, good night, y'all. You're all the best. Take care.